As we get ready to study calculus, one of the important things that we'll need to be able to do is to find the symmetry of a graph. You have already dealt with symmetry in geometry, but we're going to in calculus treat it a little bit more formally. At the end of this lesson, you'll be able to determine whether a graph is symmetric with respect to the x-axis, the y-axis, or the origin. When a graph is symmetric with respect to the y-axis, if whenever xy is a point on the graph, negative xy is also a point on the graph. Kind of in plain English here, the y-axis will act like a mirror. So you'll notice on this first problem, the graph y equals x squared. You'll notice that y-axis is acting like a mirror. Every point is reflecting itself over the y-axis. And you'll notice here we have the point, the point 1, 1 is on the graph, and then you'll notice the point negative 1, 1 is on the graph. So you notice it doesn't matter whether the x is positive or negative, we'll get the same y value. And then the same thing over here, we've got the point 1, 0.5 on the graph, and then over on the reflected side, we have negative 1, 0.5 on the graph. So no matter what the x value is, positive or negative, we get that same y value. So when we test it formally, we'll replace the x by negative x and hopefully get an equivalent equation. So let's try one where we get to test it. Let's show that y equals x squared plus 3 is symmetric with respect to the y-axis. Notice that this time we don't have a picture, and we probably won't be given a picture. This is going to be non-calculator. So to show that it's symmetric with respect to the y-axis, we're going to replace any x that we see with a negative x. So notice I'm just replacing it, and then I'm just going to try to simplify the problem a little bit. We'll have y equals, when I have negative x squared, that means negative x times negative x, so that will give me just x squared plus 3. And you'll notice that my original equation was y equals x squared plus 3, and my new equation is y equals x squared plus 3. So we have now just shown that this is symmetric with respect to the y-axis. And I'm just going to show you a really cool little feature. Oopsie, wasn't a cool feature. If we put a little box, that means end of proof. We have shown what we set out to show. Next, here we go. Okay, a graph is symmetric with respect to the x-axis. This time the x-axis is just going to act like a mirror. So whenever we have xy on the graph, we'll also have x negative y. So let's find a good one here. Let's say we've got the point 4, 2 on the graph, and then you'll notice down here we have 4, negative 2, and you'll notice that x-axis this time is acting like that mirror. Points are just reflecting over that x-axis. So you'll notice this time, if we replace y by negative y, we'll get an equivalent equation. They're both on that graph. So let's do a test here. This time let's show that xy squared equals negative 10 is symmetric with respect to the x-axis. So this time we'll replace any y we see with a negative y. Right, and again we'll simplify. Negative y squared again means negative y times negative y, which is just y squared, equals negative 10. Please notice I started out with xy squared equals negative 10. I ended up with xy squared equals negative 10. Since they're the exact same equation, we have just shown that it's symmetric. End of proof. Right, the last thing we're going to look at is a graph symmetric with respect to the origin. This time, before I read through those notes, basically what's going to be happening is if we were to rotate the equation 180 degrees, so if you were to turn your paper upside down, you should get the exact same graph. So if xy is a point on the graph, then negative x, negative y will also be a point on the graph. The graph is unchanged by rotation of 180 degrees about the origin. So let's see here. Let's say we've got the point 1, 1. Notice that after if I flipped my paper upside down, another point on the graph is negative 1, negative 1. So both the x and the y values change this time, and I get an equivalent equation because they're both on the graph still. And then same thing you'll notice with over here, the sine graph. If you were to turn this graph upside down or rotate it 180 degrees, you would end up with the exact same graph. So let's do another test here. Let's show that xy minus the square root of 4 minus x squared equals 0 is symmetric with respect to the origin. So this time we need to show that if we replace x with negative x and y with negative y, we'll still get that same equation. So wherever I see an x, I'll put negative x. Wherever I see a y, I'll put negative y. Okay, and now from here, negative x times negative y is just xy, and then minus the square root, 4 minus, on this one, if I have negative x squared, that just equals x squared equals 0. And you notice the graph that I started with, or the equation that I started with, is exactly the same as the graph I ended up with. So, end of proof. And there we go. That's how you do it.